Question 1. What does the Fermi level represent in a semiconductor at absolute zero temperature? At absolute zero temperature, the Fermi level indicates the theoretical maximum energy state occupied by electrons. Question 2. What physical event occurs during the process known as impact ionization? Impact ionization happens when a high-energy charge carrier collides with the crystal lattice, knocking an electron free and creating a new electron hole pair. Question 3. Which material property allows a direct bandgap semiconductor to excel in making LEDs? Because direct bandgap materials don't require an electron momentum change to recombine, they efficiently emit photons, making them ideal for light-emitting diodes. What classic electrical equation links carrier drift velocity to an applied electric field? Drift velocity is directly proportional to the applied electric field, with the scaling factor defined as the carrier mobility. Question 5. What is the name of the energy band located directly above the forbidden bandgap? The conduction band sits directly above the forbidden bandgap. Electrons here have enough energy to break free and freely conduct electric current. Question 6. How does adding acceptor impurities alter the position of the Fermi level? Adding acceptor impurities creates p-type material, which shifts the Fermi level downward closer to the valence band. Question 7. What basic physical barrier limits how fast electrons can drift through a crystal lattice? As electrons accelerate through a semiconductor, they continuously collide or scatter due to thermal lattice vibrations and ionized impurities. Question 8. What happens to a semiconductor device when it enters the state known as velocity saturation? At very high electric fields, carriers reach a speed ceiling called velocity saturation because excess energy is lost to the lattice as fast as it is gained. Question 9. In what year did the research team at Bell Labs successfully demonstrate the first solid-state transistor? The historic breakthrough occurred in December 1947, when Bell Labs demonstrated the first working point contact transistor device. Question 10. What type of crystalline defect involves a missing atom from a normal site in the crystal lattice? A vacancy defect is a type of point defect in a crystal lattice structure where an atom is completely missing from its regular position.